Hello and welcome to Cloud Tech 10 for the 27th of November 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. With the Azure Container Agents for Jenkins, you can integrate with the Azure Container Service and Azure Container Instances. This tutorial has been published which walks through the process of using Azure Container Instances as Jenkins build agents. Using this method, you can spin up containers as needed to perform Jenkins build tasks and remove them when complete, allowing you to take advantage of Azure's per second billing for container instances. If you don't already have a Jenkins deployment, you can easily deploy one in Azure by following the simple steps here. This link will take you to Jenkins in the Azure Marketplace. Click Get It Now and then Continue, and you'll be taken to the Azure portal. Click Create, then fill in the usual details for deploying a virtual machine, including a machine name, username and authentication details, resource group and location. Give your Jenkins instance a unique domain name so that it can be accessed over the internet, and that's all the information needed. A Jenkins instance will now be deployed into Azure. Once deployed, make a note of the full DNS name for your new deployment, then open that URL in a web browser. You'll see a page like this with instructions on how to securely access Jenkins using SSH port forwarding. Open a command prompt and paste the command from the previous page in, remembering to change the username here to match the username you specified earlier during the deployment. Once connected, you can obtain the initial password for Jenkins using this command. Now that SSH port forwarding is enabled, go back to a web browser and go to localhost on port 8080. You'll see this prompt to unlock Jenkins, so paste in the initial password we just obtained and then click the option to install suggested plugins. Once that's complete, provide some details to create a first admin user that you'll use from here onwards to access Jenkins. Let's check that Jenkins is working. We'll create a new job, name it My Sample App and choose Freestyle Project. Under Source Code Management, we'll specify a Git repository, and under Build, we'll add a build step to invoke a Gradle script using the Gradle wrapper option, and specifying Complete for the wrapper location and Build for the tasks. Under Advanced, set the root build script to complete and click Save. We'll click the Build Now option and wait a few moments for the build process to complete. Once done, click on Workspace and then navigate to Complete, then Build, then Libs, and check that we can see the jar file that's just been built. That's all looking good. So now, let's configure Jenkins to build using Azure Container Instances. We're going to configure Jenkins so that the Azure Container Instance-based agents can communicate with the Jenkins master. From the Jenkins dashboard, choose Manage Jenkins, and then click Configure System. Scroll down to the Jenkins URL and paste in the DNS name for our Jenkins deployment. Now back to Manage Jenkins, and this time choose Configure Global Security. Scroll down to the Agent section and set a fixed port. I've opted for port 12345. The exact port number isn't important, as long as the port is not in use. We'll save that, then next we need to allow port 12345 through the Azure Network Security Groups. We'll return to the Azure portal and choose the Network Security Group. We'll go down to Inbound Security Rules and add a rule to allow any traffic on port 12345. Back in Jenkins, we can check in the Manage Plugins section to see that we have the right plugins configured. If you're using the Azure Marketplace image, as we are here, then the Azure Container Agents and Azure Container Service plugins are installed by default, along with a selection of other Azure-related plugins. Now we create a service principal so that Jenkins can access our Azure subscription. The quickest way to do this is with the Azure Cloud Shell using the Azure command line tools. We'll use the AZ-AD-SP create for RBAC command, specifying a name and password to use. Once that's been created, make a note of the output of the command, as you'll need it shortly to configure Jenkins. Back in the Jenkins dashboard, choose Credentials, then System, then Global Credentials, and we select the Add Credentials option. For kind, we choose Microsoft Azure Service Principal, and then we'll need to paste in our Azure subscription ID, and then from the output of the command we just ran to create the service principal, the client ID, which is the app ID, the client secret, which is the password, and the tenant ID. We'll give this an ID of MySP and a description. Click the Verify Service Principal button, and Jenkins will verify that the details provided are correct. Now we're ready to configure the containers. I'll return to the Azure Cloud Shell and create a new resource group to hold the container instances that we'll be working with. Back to the Jenkins dashboard and into Manage Jenkins and Configure System. Scroll to the bottom and the Cloud section and choose Add a New Cloud and select Azure Container Instance. Choose the service principal we created earlier from here and the resource group we just created from here. Under Add Container Template, we'll provide a name and a label, and we're going to provide the details for a Docker image that contains a slave with Java build tools. Under Advanced, we'll change the retention strategy to Container Idle Retention Strategy. Finally, it's time to configure a new build that will use Azure Container Instances. We'll go to New Item, call our new build Demo Project 1, and choose Freestyle Project. We'll use the option to restrict where this project can be run by specifying the label we defined earlier when we set up the ACI cloud. Under Source Code Management, we'll specify the Git repository for the sample application that we're going to build. And under Build, we'll add a build step to invoke top-level Maven targets and add Package to the goals. We're ready to build. We click Build Now, and a build is queued. The first time we run, it takes a short while for the Azure Container Instance to be started up with the Docker image we've specified. But after a short while, we'll see an ACI Container Instance, and the build will start to progress. The Container Instance's status then changes to idle, so it looks like it's finished. Let's go to the project, and we can see that the build has completed successfully. Azure Advisor has been updated with a new dashboard showing recommendations across high availability, security, performance, and cost savings. There's now the option to download the recommendations as a CSV or PDF format file, so you can share recommendations easily with those who may not have access to the portal. Azure Advisor also has some configuration options. If you want to exclude some resources from recommendations, such as development resources, you can select groups to be included or excluded here. For the analysis of lightly used virtual machines that could be resized or shut down, you can modify the average CPU utilization value that causes this rule to be triggered. Azure SQL Data Warehouse uses decoupled compute and storage to allow you to choose a performance level that matches your needs. However, more savings can be made by further automating the configuration. This chart shows an example of a customer's data warehouse usage, which shows they have predictable spikes in their activity. During quieter periods, the amount of data warehouse units allocated can be scaled down and then scaled up as needed. A set of Azure functions has been created to show how this can be achieved. From the GitHub repository here, click the Deploy to Azure button and you'll be taken to the Azure portal. We need to provide some information, starting with a resource group where these new items will be created and an Azure region. We provide the details for our SQL Data Warehouse resource group, server name, and data warehouse instance name. We need to choose a unique name that will be used for the web services that will be deployed. We can optionally choose a storage account type, and then we provide the details for a previously created service principal. So we provide the Azure Active Directory tenant ID, Azure Subscription ID, the service principal application ID, and secret key. We choose the website's time zone so we can ensure that the scale up and scale down operations will take place when we expect them to. And we can choose initial values for when we want to scale up or down. We click the purchase button and then wait for the deployment to complete. Once it's done, you'll see we now have a storage account, app service plan, and an app service for Azure Functions. If we open Azure Functions, we can see that 5 functions have been defined. If we look at the DW scale up trigger function, we can see this is a timer triggered function that changes our SQL Data Warehouse instance to the DW 400 level. Clicking on the Integrate tab, we can see the schedule this function runs on is defined by this variable. So if we take a look in the application settings, we can find the corresponding variable and set its value according to the timings we want to use to scale up. Or alternatively, we can just override the value directly to set a new schedule. We can modify the script to set the required data warehouse unit allocation, modify the schedule, or we can copy this function to create more functions which can then be configured to execute on different schedules or to account for more complex scenarios. New features for Azure Policy are now in public preview. Azure Policy allows you to apply controls across your Azure environment for governance and compliance purposes. Until now, this all had to be done through command line tools, but now there's an Azure Policy UI. To use Azure Policy, you first need to enroll in the preview. By default, when you first use the service, you'll see this sign up page. You'll need to select the Azure subscriptions you want to enroll and then wait for up to 30 minutes for this to be set up. Once that's done, you're ready to go. The Getting Started section explains more about Azure Policy and how to get started deploying policies or initiatives, which are a method for grouping multiple policies to simplify management. The overview section shows us the current state of our environment, including that I currently have 1 non-compliant policy and 8 non-compliant resources. In the assignments section, I can see the policies that are currently deployed and I can assign new policies and initiatives. I can scroll through this list of predefined policies. Let's choose this one, which looks for network security groups that aren't configured with strong enough rules. I assign a scope that the policy will be applied to, which can be the entire subscription or selected resource groups. Or I can apply the policy broadly and then choose scopes to be excluded from the policy. Once I click Assign, the policy is applied. Now in the compliance section, I can see the current status, including the new policy I just assigned. From here, I can drill down to get more info. If I select this Manage Disk policy that has 8 non-compliant resources, I can see the details of the affected items. I can also create and deploy custom policies from the portal. The policy still needs to be defined using a JSON format template, but there's a reference in the Azure Policy documentation to help with this. There's also a GitHub repo with a selection of template definitions you can make use of.